Okay, the next example we're looking at is how to solve a quadratic equation that's not equal to 0. So you'll see here, we know it's quadratic, it has a 2 as the leading exponent, but it's not equal to 0. So what we do is we simply rearrange, bringing that 42 to the left by changing its sign. Now that we have it equal to 0, say it's zeroed out, now we will use our zero product property and we'll factor. So remember, when we factor our quadratics, it's going to look like this with our leading coefficient of 1. If you need to, go off to the side and do your table. Remember, where we're looking for the products of the factors, for the product of A and C that give me a sum of B. And so my A is 1, my B is 1, my C is -2. So 1 times -42, I don't think I said that right, -42, and gives me a product of 1. All right, so my factors of 42 are 1 and 42, 2 and 21, 3 and 14, 4, 5, 6, and 7. And I'm already have in my head, I know I'm looking for a difference of 1, and so I'm going to focus on that 6 times 7. And you guys will get better and you'll get faster at knowing your factors and knowing which pair to use here. Now I know when I multiply, I should get a negative. So I always use my, my multiplication rules of integers first. That kind of helps weed out when it comes to adding and subtracting. I should say adding, combining like terms is what we're doing. Alright, so I know that 1 should be negative and 1 should be positive to give me a -42, but I need a positive 1 here. So thinking of my combining like terms with integers, adding integers, if I want a positive answer, then that means I should have more positives than negatives. So that means my small number is a negative, and my big number, it should be the positive, and that will give me a positive answer. So make my small a negative, which would be my 6, and when I check that, -6 plus 7 is a positive 1, so those are my winners here. So I will go back over here and replace this with -6 and a positive 7. Okay, and now we will just set each of those equal to 0, and using my inverse operations, I would add 6 to both sides, subtract 7 from both sides. So our answer could be +6 or -7 in this case. Now, if this is a word problem, then we would just make sense of, should it be the positive number or the negative number? So if we were talking about time or distance, it would be the positive. And if we were talking about owing money, then it would be our negative solution. Okay, let's continue practicing where we are solving a quadratic equation that's not equal to 0. So first, before we can apply the zero product property, I must zero this equation, meaning I need to get it equal to 0, and I do so by simply moving that term, whatever term is by itself, over to where I make it equal to 0. And sometimes we have to move more than one term, which is fine. Okay, now I have it equal to 0, and now I can factor. First, better check, make sure there's not a greatest common factor of 2, 9, and 5. And their greatest common factor is 1, meaning they're relatively prime. Can't factor anything out other than 1. And we know 1 doesn't change anything when we factor out. Alright, so identifying my A, B, C, I'm going to go ahead and use my little chart here. -2 times 5 is -10, and my B is -9. Remember, it's alphabetical order A, B, C when it's in standard form. So A is -2, C is 5, and B is -9. Okay, my factors of 10 are 1 and 10, 2 and 5, which I know 2 and 5 are not going to get me to 9, so I'm going to focus on this 1 and 10 here. If I multiply, I should get a negative, so I know that one of those is a negative and one has to be a positive, and I put an add sign. I knew that was wrong. It's multiply. And now, this is the tricky part, is really making sure my integers are right in adding. So if I know one has to be positive, one has to be negative, then when I add them, I get a negative. So I'm looking for when I add, I get a negative, meaning I had more negatives than positives. So my small number should be positive, my big number will be the negative here. So I make my bigger numbers negative, and then I combine them. 1 minus 10 is negative 9. There is my solution. Okay. Now remember, when our trick to factor by grouping, which is a little bit of a shortcut, is I'm going to take my two numbers, okay, and I'm going to divide them by my leading coefficient, which was negative 2. So I would get x equals oh, no, not equals. Look at me. It's Monday today, so that's where I'm going to be making mistakes here. 1 minus 1/2, and x negative 10 divided by negative 2 is a positive 5. Okay, so we're looking for the one that did not divide nicely. I would have gotten a decimal. So the trick here is to move that in front, and that would show you my leading coefficient of negative 2x. So making sure I have my negative. Okay, moving that 2 in front of my x, so I get 2x minus 1 and x plus 5. Okay, now I want to zero those, so I get 2x minus 1 equals 0. X plus 5 equals 0, and when I solve that, when I move my 1 over, it becomes a positive 1. Right, and then we'll divide both sides by 2, and x equals positive 1/2. When I subtract 5 from both sides, I get x equals negative 5. So that is our solution. So you see, we're just building on what we already know about factoring, where a is greater than 1, using that trick of kind of a shortcut of factor by grouping. So if you Google how to do this, they're probably going to give you an example of factor by grouping and not using the shortcut that we're using in class.